Okay, so this is going to be review for your test number 2. Exam number 2. So it'll be very similar to it. There will be 18 questions. And so the first one would be, suppose that a class has 10 Republicans, 11 Democrats, and 8 independents. Okay. What would be the probability? What is the probability of selecting one person class that is independent? Okay, what would you use? So you gotta remember, you gotta use a formula. What's the formula for probability? The formula for probability was what? Parts over total. Okay. So I know the parts be independent, so that's right. And so to figure out the total, we're going to add the Republicans, the Democrats, and the independents. That gives me 29. And now I'm going to divide 8 by 29 is 0.275862069. And remember, where do you round? You got to round to 3 places. So I have to have 3 digits, remember? So because this 4th digit is an 8, and I have to increase that 5 to 1. So this would make it 0.276, or you guys want to write it in percentage, 27.6%. I will take either one. Either one will be sufficient. Okay, so that's an example of number 1. Second question, I'm going to ask, list all possible events that can occur if a couple plans to have three children. Okay, so I don't want just the number. I want you to list all of this different possibilities on like the list. So I know boy, 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 girl, 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 boy, boy, girl, boy, girl, boy, boy, girl, 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 boy, girl, boy, girl, and girl, boy, boy. Right. But this is what I'm looking for, not the grand total of 8 outcomes. I know there's 8 outcomes, but I want the list. I want the list. And how do we remember? Remember how I determined how it was 8 each child? For each of the 3 children, there's 2 genders. There's 2 genders. Two genders. And you multiply them, and that gives you your 8 outcomes. Okay, so we want this. Okay. All right, number 3. Let's see. Suppose that the probability of me purchasing a chicken sandwich from Golden Chicken is 0.57. Okay. What is the complement of that? Okay, so because this is in decimal, I am going to subtract this number from 1. So if I subtract 0.57 from 1, I get 0.43. Be my complement. If this number was in percentage, let's say that this was 57%. So instead of subtracting 57 from 1, you would subtract 57% from 100%. That would give me 43%. So this is in percentage, and this one is in decimal. Don't get those confused. When it's decimal, you subtract from 1. When it's percentage, you subtract from 100. Okay. All right, so number 4. Is the addition rule. Okay, so for the addition rule, I am going to make a table. Okay, so this table is going to have females and males. And so they asked males and females whether corporal punishment was used on them when they grew up. That includes spanking with the belt, with the hand, with the hammer, with the machete, kneeling down in the corner with uncooked rice, anything of that nature. Anything with corporal punishment. Used, corporal punishment used. I'm going to just put corporal used. Corporal not used. Okay. And let's see. Or no, let's see. Girls, were y'all spanked a lot? Were y'all traviesas? Probably not. Probably so. 12, maybe 2. And males, oh yeah, they were bad. 15 and 6. There you go, something like that. You know where you're at. You know where you're at. I mean, you know what you did wrong. Okay, so remember, given a table, you remember what you're supposed to do? You're supposed to add the rows and the columns. So I'm gonna add the rows. 14, this is 21, this is 27, this is 8. So we should have a total of 35. Okay. And the question for number 4 would be, find the probability, right, using addition. Cool. What's the probability that we choose a male or used corporal punishment? Okay, so you remember we had 2 of them. We had the intersection and the disjoint. Okay, which one do we use? Well, because these 2 events are from 2 different things. This one's the gender and this is the question. Because they're 2 different, this one's going to be an intersection. So we're going to do probability male plus the probability of used corporal, okay, minus where they intersect. Barely read it. Corporal, that's corporal. Okay. So remember, it's parts over total. So all of them are going to be over 35. Right? Okay, so they're all over 35. So we're going to get the total. Total of the males is 21. Total that used corporal punishment, total used is 27. And where they intersected, right, is going to be where? So let's see the drawing. Male, 21, 27, 15. So that should be 15. So we're going to go ahead and add 33 and divide 0.94285714229. And remember, we got to round to 3 places. So that would be 0.943 or 94.3%, whichever one you like. Move it up so you guys can write. Pick up. Forget it. Okay. All right. There you go. So there's number 4. Okay. Now we're going to do number 5. I'm going to use the same table. Okay. I'm going to do the same table. Write it again while you guys copy that. I'll scoot it up so you guys can see it. corporal used, corporal not used. All right. 12, 15, 2, 6, 27, 8, 14, 21, total is 35. Okay, now, the next one I'm gonna ask you is, right, find the probability of female or male. Did I use male or? Yes, I did. Remember the word or. Or means the addition rule. Don't forget. Addition rule. The addition rule. We gotta use the addition rule when it says the word or. Remember that. The previous one I should have circled it. Okay, so now I gotta figure out, is this the one gonna be intersection or disjoint? Well, it's gonna be disjoint because these two events are the same. It's coming from the same. It's gender. So I know that I'm going to use the disjoint one. So female plus male. So they're both over 35. I'm going to get the total for the females is 14. Total for males is 21. And so you should get 35 over 35, which is 1, or you prefer to write it in percentage. It is 100%. I'll leave it up to you how you all want to write. So this one was disjoint. The other one intersected. Okay. All right, so far so good. All right, let's go to the next one. This one's going to be the multiplication rule. Okay, so make it up. This is number 6. All right, suppose you were Apple assembling iPhones. Okay. Each day you assemble 25 iPhones. Okay. 14 of which are good. Okay. Find the probability that both you choose two iPhones are good. Actually bad. We should do bad. They are bad. Okay. So based on what we have, we know that 14 of which are good. But what about the bad ones? How would you determine the bad ones? Well, we know that you make 25 of them a day, and 14 of them are good. So to figure out the bad, you're going to go ahead and subtract 25 minus 14, which I think ends up being 9. No, 11. 11. 11 are bad. Okay. And I want to find the probability that two iPhones are bad, and we're going to do it with replacement. Okay, so I want to figure out bad and bad. But it's with replacement. Okay, so how do I do it? Well, I got to find the probability of bad, and we got to multiply it times the probability of bad. So remember your probability formula is parts over total. So it's going to be 11 over 25. And because it's with replacement, I got to put it back in the batch. 11 out of 25. You multiply them out. Point 1936. Remember, I got to round to 3 places, so I got to have 3 digits. So this becomes 0.194, or you want to write it in percentage, 19.4%. Remember that the fractions come out the same because it's with replacement. Okay, now let's do the same thing, but we'll do find the probability of bad and bad, and we'll do it without replacement. Okay, let me see, remember how to do that. So remember, we're doing the probability of bad times the probability of bad, take away a bad. Right? So still is 11 over 25, right? But when we do the second probability, we're going to figure out the bad, taking a bad out of the batch. So if we take out 1, that becomes 10, but that also affects the denominator, which makes it 24. Right? So without replacement, you're taking it out. You're taking 1 item out of the batch, which affects both the total and the amount of bad in the batch. And so I'm going to calculate it. And I get 0.18 and a whole bunch of 3s after it. But you know, it keeps going, but I remember I got to round it 3 places, so that would be 0.183, or if you want to put it in percentage, 18. So the key words for this one is with replacement, and the other one was without replacement, and this one was with replacement. With, downs, without. Okay, they stay the same, they decrease. Okay. All right. The 8th question is going to be a conditional probability. Okay, so we will do another table. I will create a table. We'll do male, female, and we'll ask a question to these males and females. What would be a good question? How many of you all drank alcohol at an early age? Let's say early age is 15 or younger. All right. So yes or no. All right. Males typically, well, I don't know. We'll do 10 and 4, 9 and 2. We'll make it simple like that. Okay. And you got to remember, you have to add your columns and rows. So that's 19, 6, 14, 11. So that would give us 25 total. Okay. And so how do you know if you have a conditional probability? Well, you're gonna have a problem that's gonna say find the probability of female. There's a line that's gonna say given. Given is the keyword. Given no. Okay. So you guys remember the formula? It was your famous one that I told you to remember. The swap and drop formula, right? The swap and drop formula? Okay, so the swap and drop formula goes like this. You have to write it out because if you don't, you're going to mess up. So you're going to swap these variables. You're going to put no and female and then divide it by the first item there, no. And so remember the top, it's going to be an intersection. It's going to be one of these inner circles, one of these inner squares, right? Where no and female intersect. So no is right there. Female, so it's 2. So you have a 2 on the top. And then divided by the grand total of all the no's. No's is right here. This is a column that goes straight down. That's 6. So 2 out of 6. So I do my calculations. 2 out of 6 is going to be 0. Whole bunch of 3s. We got around to 3 places. So this would be 0.333 or 33.3%. Remember, mine means given. Given. Okay. All right. Moving down. Number 9 is going to be, I'm going to give you a table. I'm going to give you a frequency distribution table. And you need to find the mean from it. All right, so let me give you a table. And let's say that our table it goes like this. We'll do zero, 1, 2, 3, 4. This is my P of X. My numbers read 0.410, 0.410, 0.154, 0.025. Oh, sorry. 0.26, sorry, and 0.02, sorry, 02. Another 0, 2 zeros, and a 2. So 002 is the last number. Right? And the question says, find the mean. Okay, so how do we find the mean? Okay, so you remember the formula for the mean? Right? The mean formula was mu equals the sum of x times p of x. Okay. All right. So remember, we got to do the inner part first, right? So I'm going to multiply my x times my p of x. So I'm going to multiply these two, put my answer there, these two, put my answer there, these two, put my answer there. You multiply the two numbers and create your third column. So this would be 0, 1 times 410, 10, 2 times 0.154 is 0.308. 3 times 0.026 is 0.078. And 4 times 0.002, 0.008. Oh, okay, let's try it again. Okay, so I am going to add, because that's what this is. So I did this part. This is the red, and I'm gonna have to add it up because that's what the sum is. I need to add up this column, and that'll give me my mean. So let me get my calculator, and I'm gonna add it up. So let's see what we're gonna get here. I'm adding them up. Okay, so 410 plus 0.308 plus 0.078 plus 0.008. I get 0.804. These you have to round to the tenths. Right. So my answer for this one would be, since I need to round it to the nearest tenths, I have the 0 next to the 8, so this just becomes 0.8. And that's your okay. Okay, so there's the mean. Okay, so I'm gonna rewrite this table, and we're gonna do number 10. We're gonna find standard deviation. Okay, so let me bump that up. So using the same table, Okay. And I want to find the standard deviation. Okay. So to find it, here's the formula. Sigma equals to the square root of the sum of x squared times p of x minus mu squared. Okay, so there's that long formula. Okay, so we already did this part already. We found the mean already, which was 0.8, but we want to use the actual number. Don't use the rounded off one. We're going to go ahead and use the actual one, which is 0.804. So this was 0.804 squared, right? And now I want to calculate this part. Okay, so let me just do it again. I'm going to multiply these again so y'all can see how we did that. 0.010, 0.08, 0.008, 0.008. This was 0.84. So that's where I got that number from. Squared. Okay, now I got to calculate this. So I first have to calculate x squared. So I'm going to go over here in my column. On the left of it, I'm going to square each of them. This would be 0, that's 1, that's 4, that's 9, and that's 16. I'm just squaring each of these numbers. That's what this is. And now I have to multiply each of those greens by my p of x. This is these numbers. I got to multiply this with this, this with this, this with this. And I'm going to put my answers here. Okay, don't forget, put lines so you won't forget, because sometimes people will do this one with the red, no, or this one with the x, no. You do it with the p of x squared times p of x. Okay, so here I go. 0 times that is 0. 1 times 410 is 0.410. So now I have to do 4 times 0.154. That is 16,616. 9 times 0.026. 0.234. And 16 times 0.002 is 0.032. I did this calculations. Now I have to sum them up. So I'm going to add, I need to add this whole entire column. So let me add that up for you. $1.292. So that 1.292 is this whole thing there. This is 1.292. And so I have to calculate this inside the square root. So I'm going to do the squaring part so you all can see it. I'm going to go ahead and square 0.804 squared. If I didn't like this, 0.808 squared gives me, 0.646416. That's the back number. 0.646416. I'm going to subtract these two numbers. gives me 0.645584. I am going to take the square root of that number. And voila, 0.803. Oh, my ink's running out. 34824. No, 205. I got to round it to the tenths. Round to the tenths. Okay, so it's going to be also 0.8. That's your deviation. Just double checking my work, because maybe sometimes I can mess things up with my calculations. Nope, I did everything right. Yep. 4 times. Checking. Just double checking. Yep. Okay. There is the standard deviation. So that was 10. Okay, so now I got to do 11 is determining whether events are usual or unusual. Okay, so if you're going to do it the long way, okay, if you're going to do it the long way, you would have to get your mean. There's your mean. There's your standard deviation. And you would have to find the minimum usual, max usual. And then you have to, they're going to give you a number to see if it's unusually high or low. But I'm going to show you the shortcut. So I'm going to give you a table. I'm going to give you the same table, the exact same table. Right. So let me write it down again. This is number 11. Determine if usual or unusual. And it's going to run out. Okay, I'm going to have to switch. This thing is not working. Okay. 0, 1, 2, 3, 4, 0.410, 0.410, 0.154, 0.026, 0.0. All right, so let's say they gave you a table and they want to know is the probability of 2 unusual or usual, right? And so what you would do is you would go to the 2. You're going to get this number, right? This number, and you want to see if it's what? You want to check to see if it's less than or equal to 0.05. Right? So is this true? Is 15 cents smaller than 5? No, it's false. So if it's false, it would be considered usual. If true, it's unusual. So you have to use this formula. The probability is less than or equal to 0.05. This is the formula. If it's true, unusual, false. That's it. That's all you do. If you're asked, is the probability of 4 unusual? Well, there's your 4. Is this number smaller than a nickel? Yes, that number would be considered unusual. Okay, that's how you do the unusual usual. Okay. All right. Number 12, you're going to need your stat disk. So let's suppose this is the binomial distribution. Okay, so I'm going to test you. I want to see if you all know how to plug in the numbers in StatDisk. I think that's the only way I showed you. I didn't want to show you all the long way because I would see it in the test and you would probably freak out. So I just want to know if you all know how to use StatDisk. So I'm going to give you questions where I'm going to give you the n. Let's say n is 15. P is 0.6. And let's say x is 9. Exactly 9. If they give you a 9 like that by itself with no descriptors, okay, this is supposed to be exact, right? If there's a number by itself, just like this, you assume that it's exact. So don't forget, it's exact. If there's just a number, plain Jane, the other ones are going to be obvious. It'll say at least or at most a number. But if there's just a plain number like this, it's considered to be exact. Okay? And so we're trying to find the probability of exactly 9. Okay, so we're going to go to StatDisk. Right? So I'm going to go and go to StatDisk. Oop, wrong one. Okay, we're gonna go to StatDisk. Oh, great, this thing's in the way. StatDisk. All right, you're gonna go to Analysis, Probability Distribution. You're gonna choose Binomial. You're gonna enter your n. Our n was 15. Your p was 0.6. Our x was 9. All right, so we'll enter those, evaluate, and remember that this column, the second column, is the exact. The third is the at most. And the fourth was at least. So my problem says it said, well, I didn't state it, but we assume that it's exact. So there's my number. I'm going to round it to 3 places because that's how it's supposed to be. 0.207. If you all want to write it in percentage, this would be 20.7%. Boom. Okay. I'll give you another one. Let's say that my n is 32. My P is 2/3. And my X is at least 12. Okay, now the issue with this is that your p-value is, I don't think StatDisk will allow you to put fractions in there. You're gonna have to change this. You're gonna have to convert this to a decimal. Okay, so let me show you how to convert that to a decimal. So you're gonna go to your calculator. You're gonna 2/3. 2/3. Okay, you enter it, and you're going to write out all those numbers. However many number of sixes and the 7 appears, that's what you're going to write down for your number here. All right, so let me count how many sixes there are. 1, 2, 3, 4, 5, 6, 7, 8. I have 8. My calculator displays 8 sixes and a 7. Do not round this number. Do not round, because if you round off, your answer is going to be off by a lot. I'm going to put here, do not round this number. Right? You're going to go ahead. That's what you're going to put in StatDisk when you go into it. Okay, so now we're going to go ahead and figure out our probability. So we got to find a probability that at least 12. Okay, so I'm going to go in StatDisk and enter those numbers. Okay, so I'm going to type in 32. I'm going to put all those numbers. I have how many? I had 8 sixes. 1, 2, 3, 4, 5, 6, 7, 8. Do not round it. 7. And we're going to do 12. I'm going to put the 12 here, not 9, 12, but 12. Hit evaluate. Okay. And remember, this first one doesn't matter, right? This one matters. The second one is the exact. Third is at most. This one's the at least. Ah, there it is. This is the at least column. So I'm going to round that off to 3 places. Unbelievable. Look at that. If I round that off to 3 places, 9, 9, 9, 8, 1, 2, 3. If I round that off to 3 places, the 4th digit is an 8, which is 9, which turns over to that. This becomes equal to 1, 1.00. So there will be 2 questions where I have you enter those items into your StatDisk. Remember, if your key is in a fraction format, you got to convert it to a decimal. You're just going to divide it out and just write out whatever your calculator displays, but don't round it. If you round it off, this is going to be off by a lot. So don't round it off. You do, I will use corporal punishment on you. Remember that. Okay. So I am going to put a word problem related to the binomial distribution. So I'm going to make one up. Okay. So suppose you take a multi-choice test. Okay. There are a total of 15 questions. Each question has 4 choices to choose from. What is the probability I don't know how to spell probability of getting at least 9 correct answers. All right, so remember, you have to find 3 items: N, P, and X. Okay, N is easy. N is 15. There's 15 questions. I know the X, it's asking for at least 9. The only issue is your P. Okay, so I know that each question has 4 choices. All right, so let's do a mock. All right, let's say number 1, you have a question and the choices are A, B, C, D. Right, those are your choices. Well, what's the probability that I get it right? Well, there's 4 choices. Of course, there only has to be one out of 4 that are correct, right? You're like wondering, why is that? Well, because that's how it's designed. There's only one of them that's right. So you have a 1/4 chance of selecting the correct one. There's a 3/4 probability of getting it incorrect. They do it on purpose so you can miss it, but we want the correct. So what do I do with this 1/4? I have to convert it. So let's convert the 1/4 to a decimal. So I'm going to do 1 divided by 4, 0.25. You have a 0.25 chance of getting each question correct. Did you know that? All right, so now we have all the items. I'm going to go to my stat disk. And I'm going to enter the numbers. So my N was 15. My P was 0.25. My X value was at least 9. So I'm going to put the 9 in there. And remember, this is the exact column. At most, here's the at least. There it is. So I'm going to round it to 3 places. So the probability of at least 9 correct is going to be 004. You have a 004 probability of getting at least 9 correct. Pretty low, huh? Pretty low. Boom. Okay, I'm going to give you another word column. So you get 2 word columns. All right, let's say, gotta think of something good. Okay, so, all right, so we'll make another one. So let's say 15. A study found that 83% of students in secondary school admitted to cheating on an exam or quiz. If there were a total of 365 students at the school, what's the probability of getting three or more students that admitted to cheat? Okay, all right, so what is your N, what is your P, and what is your X? Okay, so your N is the total. There are 365 students. My P is 83%, which is really 0.83, right? Because I got to change it to decimal. And they want to know what's probably getting 333 or more. Oh, whoa, that's too many. Hold on. I meant 363. My bad. 360. Yeah, they're gonna be here the whole day. 363 or more. My bad. Okay, or more. So we want to find the probability of 363 or more. Okay, so we're gonna type these numbers in. We're in trouble. That's how corporate punish was invented. All right. So we're gonna put 365.83, and we're gonna put. Oh, we're gonna put. Oh, we can't put this or more. Yeah, we can. It's 363 or more. So I'm gonna put 363. 363. All right. So in the problem, it says 363 or more. So we're looking at the titles. Look at the titles. This is just P of X. This is X or fewer. And this one says X or greater. I think ours was 363 or more. I think more and greater are the same. So here it is. It is 0.00. It's just plain zero. This is just plain zero. This is not. This one is not 0 plus, because you see there are zeros, straight zeros. So our answer is just going to be 0.000. This one's going to be a straight zero. If there were digits behind here, then it would be 0 plus. I think we talked about that in class, didn't we? Am I right? Am I right? Am I right? See, they're all straight zeros, so it's going to be 0. We should have done a poll. How many of y'all cheated in secondary school, huh? How many of y'all cheated? Tell your parents. Okay. Number 16. How do you find the mean from a binomial distribution? Suppose I think there are 26 students. 20 students in the class. Probability of a student wearing a mask out in public is 92%. What is the mean? Okay, so you're gonna identify your N. All you need is your N and your P. Your N is 20. Your P is 0.92. You're gonna go ahead and enter it in your stat disk. Twenty. 0.92. We don't need this number anymore. All we're looking for is these bottom numbers here. And remember, you're gonna round your mean to the tenths. So your mean is 18.4 is your mean. Round to the tenth. Ah, you don't have to round it. It's already done. So let's continue with that problem. What would be the standard deviation? What is the standard deviation? Well, it would equal to, well, the actual number is 1.2133, but I got to round it off to one place, the tenth. So this would equal to 1.2. There is your standard deviation. Let me show you all. Here it is. Uppity up, up. Boom. Now to the test. Okay, 18 is still related to 16, 17, 18, right? So my question is this to you. Is having having 18 students wearing masks out in public. Unusual. Okay. All right. So what you have to do is you're gonna find your max usual and your minimum usual. You remember the formulas, right? It was the mean plus 2 times the standard deviation And the other one was minus 2 times standard deviation. All right, so here's my mean. There's my standard deviation. I'm going to go ahead and plug it in. Let's find the max first. So this would equal 18.4 plus 2 times 1.2. Okay. I'm going to take on my calculator. 18.4 plus 2 times 1.2 gives me 20.8. And the other one, I'm going to calculate 18.4 minus 2 times 1.2. That gives me 16. So here are my two numbers. Here's my max, my minimum. Here's the number that you need to check. So this is 18. Where does 18 fall? Does 18 fall in between, or does it go beyond the max, or does it go below the minimum? 18 goes right in the middle. So 18 is considered low, right? Because it falls in between. I'm writing terrible. All right, so this is your review, guys. This is your review to your test. It's going to be very, very similar to it. Okay, so work on your homework. Do it, and you should be ready for the test. It'll be very similar. Make sure that you know use StatDisk, have it handy, and your rounding rules. Don't forget, we went over the rounding rules in class. Don't forget the rules. Don't forget. All right.